So when it comes to double or triple bonds, there's all kinds of examples out there. And these are just a couple of examples that happen. So carbon dioxide we just showed had a double bond. This crazy thing is called methyl cyanide. It's actually used a lot in making compounds and stuff, but it has a carbon-nitrogen triple bond. That's the cyanide bond, and it's actually pretty strong. In the upper right-hand corner, we have acetylene, also called ethine. It has a carbon-carbon triple bond. So there's double bonds, triple bonds, all kinds of different bonds are possible. Now, we remember from earlier, as the number of bonds goes up, the length between the two atoms goes down. So a double bond is shorter than a single bond, and a triple bond is shorter than a double bond. So the bonds actually get closer together as the number of bonds go up. And we'll talk about this more later, but it is kind of an interesting thing. You do have more energy when you have a double bond versus a single bond, and a triple bond would have even more energy than a double bond. Some of the atoms on the periodic table can violate the octet rule and get away with it. So in the example I showed earlier that nitrogen had 5 bonds, that certainly breaks the octet rule, and that's not allowed. So let's talk about when you can break the octet rule and when you can't. So some atoms can go under the octet rule, like they can have only 3 bonds around the central atom, or even sometimes 2. So let's look at boron trifluoride, which is actually a stable molecule. Boron would be the central atom. Boron has 3 valence electrons. Fluorine is 7, and there's 3 of them. So 7 times 3, 21, plus 3 from boron, that would be 24 valence electrons, or 12 pairs of electrons. And when you complete the Lewis structure, boron's in the middle, 3 fluorines around the outside, but notice here in this version, boron has only 3 pairs. And this is definitely a stable configuration for boron. If you have boron, aluminum, gallium, or beryllium, they can actually go under an octet. And boron, aluminum, gallium will be happy a lot of times with just 3 bonds around them. Beryllium can actually get by sometimes with only 2 bonds around it. There aren't too many of these that go under the octet. Most of them want to have at least an octet, but these atoms can go under. Now notice that carbon, nitrogen, oxygen are not on this list. They will never have less than 4 pairs, all right, and that's important. But boron, beryllium, aluminum, gallium, they can go under the octet and be okay. Some atoms are able to go over the octet rule. One example of this is sulfur tetrafluoride. Let's build the Lewis structure. Central atom, sulfur, less electronegative than fluorine. Fluorine's the most electronegative of all. Sulfur has 6 valence electrons, fluorine has 7 valence electrons, and there's 4 of them. So 7 fluorine times 4 fluorines would be 28 valence from just the fluorines, plus 6 for sulfur. That's 34 valence electrons, or 17 pairs. So when you build the Lewis structure, put the sulfur in the middle, fluorines on the outside. Give the outer atoms a filled octet first, and if you have any left over, put it on the central atom. And when you do that, lo and behold, sulfur ends up with an extra lone pair on it. And this is actually a stable configuration for sulfur. In this case, it has 5 pairs of electrons around it. It has 4 bonding pairs, 1 to each of the fluorine, plus a lone pair. And so what's important here is that this is actually very common outside of the second period. So periods go left to right on the periodic table. The second period would be starting with lithium and going over to neon. And if you're outside the second period, like third period, fourth period, etc., sulfur, selenium, tellurium, these kind of things, they can have more than 4 pairs. It's also important to recognize then that the second period will never have more than 4 pairs. So what that means here is, again, carbon, nitrogen, oxygen, these things will always have 4 pairs. They won't go under, they won't go over, they have to have 4 pairs. So we're seeing here that boron, beryllium, aluminum, gallium, they can go under 4 pairs. And if you're in the third period and lower, you can have more than 4 pairs, like the sulfur here. But it's also important that carbon, nitrogen, oxygen, never more than 4 pairs. Atoms in the first and second periods cannot go over the octet rule, and that's a hard rule. I've never seen exceptions to this. On the other hand, third period and greater, you can go over the octet rule. It's not that they have to. Like a lot of sulfur compounds have just an octet around them, which is great. But if they need to, they can go over the octet rule. And we'll see examples of how this works out here, definitely.